Hello everyone, let's go ahead and take a look at algebraic fractions, which are of course fractions with variables. Now what can you do with fractions? Well, the operations of course that you can perform are addition, subtraction, multiplication, and division. And what we're going to do is we're going to see that there is consistency between what you do with the algebraic fraction case as with the arithmetic fraction case. So just to review, let's go ahead and take a look at the arithmetic fraction case first. So say for example, if we have 1/3 plus 4/5 minus 3/2, what is that equal to? Well, of course, when we add or subtract fractions, we need to get a common denominator. And the common denominator will be the greatest common factor of all the denominators that are in the expression. And of course, we have 3, 5, and 2, so the greatest common factor or the greatest common denominator would be 30. So if I take 1/3 and I multiply it by 10 over 10, if I take plus 4/5 and I multiply it by 6 over 6, and I take negative 3 over 2 and I multiply it by 15 over 15, I'm not changing the expression, I'm just changing the form of the expression so that I have a common denominator. So this is going to be 10 over 30, this is going to be plus 24 over 30, this is going to be minus 45 over 30, and once I establish a common denominator, then I just add or subtract the numerator. So I come up with 10 plus 24 minus 45, and that's going to be equal to negative 11 over 30. So if we want to go ahead now and extend that to an algebraic fraction case, it's exactly the same thing. Take a look at what happens. Say for example I have 2k over 5 minus 2m over 3 plus 3/2. Okay, again, we're looking for the greatest common denominator. In this case again, it's going to be 30. So I take this particular term here and multiply it by 6 over 6. This particular term here, multiply it by 10 over 10. Multiply the positive 3/2 by 15 over 15. And what I come out with is 12k over 30 minus 20m over 30 plus 45 over 30. And sure enough, I just add or subtract the numerators with a common denominator now of 30 to come up with 12k minus 20m plus 45 all over 30. So notice that if you can do the arithmetic form, then you can surely handle the algebraic form as well. Now let's take a look at multiplication. If we have 1/3 times by 4/5, of course, basically what we do is we multiply the numerators together and multiply the denominators together to come up with 4 over 15. Now, if we wanted to go ahead and take a look at what happens with the algebraic case, we have m over 3 times by 3n over 7m. Again, it's the same process here, m times by 3n divided by 3 times by 7m. Now what I'm going to come out with is 3mn, and notice that I'm going to leave the 3m times it by 7, which is exactly the same overall simplified expression. The reason why I'm going to leave it in this form here is because if I have common factors in the numerator and the denominator, I can go ahead and cancel them out. Only now if they're factors, not terms, factors. So notice that everything here is being multiplied, so therefore I know that all of those are factors. And everything down here in the denominator is also being multiplied together, which means that they're factors. Therefore, I can cancel the 3, and I can also cancel the m. And so therefore what I'm left with is just n over 7. Okay, let's take a look at the division case. Here's the arithmetic form. 4/5 divided by 9/2. Remember that we multiply by the reciprocal of the second fraction, and we come out with 8 over 45. Now here's an algebraic fraction, where we have one fraction divided by another fraction. Notice that it's the same consistent result in the sense that I'm taking this fraction multiplied by the reciprocal of that fraction, and I come out with x squared minus 25 over x plus 5. Now, the question is can I actually go ahead and cancel anything from the numerator and the denominator for this particular fraction? And the answer is no. The reason why again it's no is because this is not factored and this is not factored as well, because I have the last operation in the numerator being subtraction. Now the one thing that you should notice though is that I can actually go ahead and factor the numerator. And the numerator is just going to be a difference of perfect squares, so I know that I can rewrite it to look like this. Okay, once I get it into that form, can I now go ahead and cancel? Well, I have an x plus 5 factor here and an x minus 5 factor there. In the denominator, I also have an x minus 5 and an x plus 5. So what I can do then is that being now that the numerator is in factor form, I can cancel that with the entire factor here. And what I'm left with is just x minus 5. Okay, so that one's a little bit tricky because we need to do a little bit of factorization in order to see the cancellation and therefore the more simplified form of the fraction. So, wrapping up, algebraic fractions are just fractions with variables. We just need to do exactly the same procedure that we did in the arithmetic case as with the algebraic case. The key though now is that being that we can actually come out with algebraic expressions like this, if we're going to cancel something from the numerator and the denominator, we need to make sure that we're canceling by common factors only. So we'll take a look at some examples the next time that we're in class to see whether or not we can go ahead and handle algebraic fractions. Until then, see you later. Bye-bye.